Question. Determine the net force acting on each of the following objects. In each case, assume that all forces acting on the object are given. A. At an instant when a soccer ball is slightly off the ground, a player kicks it, exerting a force of 25 Newton at 40 degrees above the horizontal. The force of gravity acting on the ball is 4.2 Newton. Direction is down. B. Two children pull a sled across the ice. One child pulls with a force of 15 Newton. Direction is north, 35 degrees toward east. And the other pulls with a force of 25 Newton. The direction is north, 54 degrees toward west. There is negligible friction acting on the sled. C. In a circus act, a performer with a force of gravity of 4.4 multiplied 10 to the power of 2 Newton on her is lifted by two different ropes at the same time. One rope exerts a tension of 4.3 multiplied 10 to the power of 2 Newton. Direction is up and 35 degrees left. And the other rope exerts a force of 2.8 multiplied 10 to the power of 2 Newton. Direction is up. Now question A. Use Fa to represent the force of the player exerting on the ball. So this force is 25 Newton. Direction is 40 degrees above the horizontal. The other force is just the force of gravity. The force of gravity is 4.2 Newton. Direction is down. Now I draw the FBD. This direction is up, also positive y direction. And this direction is right, also positive x direction. And I draw the FBD of the ball. This dot represents the ball, and this is the force of gravity. And this is the force that the player exerts on the ball. And this angle is 40 degrees. Now I just analyze the force that the player exerts on the ball. So this is the force Fa that the player exerts on the ball. And this is just the force Fax, its horizontal component. And this is just the force Fay, the vertical component of Fa. And this is a right angle. This angle is 40 degrees. And from this graph, we can know that the force Fax just equals Fa multiplied cosine 40 degrees, and equals 25 multiplied cosine 40 degrees, and equals 19.15 Newton. And the force Fay, its vertical component, equals Fa multiplied sine 40 degrees, equals 25 multiplied sine 40 degrees, equals 16.07 Newton. Now we can get the x component of the total force, sigma Fx equals Fax, because on the horizontal direction there is only this force Fax, and this equals 19.15 Newton. And the vertical component of the total force Fy just equals Fay Fay is the vertical component of the force that the player exerts on the ball. I use Fay to minus Fg. Because the direction of Fg is down, it's opposite to the positive direction up. So here is minus. And this equals 16.07 minus 4.2 and equals 11.87 Newton. Now I draw the graph. So this vector is the force sigma Fx, and this vector is the force sigma Fy. It's the vertical component of the total force, and sigma Fx is the horizontal component of the total force. And this vector is just the total force, sigma F. And this angle is a right angle. This angle is theta. And from this graph, we can know that the magnitude of the total force equals square root the x component of it square plus the y component of it square, and this equals square root 19.15 square plus 11.87 square, and this equals 22.53 Newton. And angle theta is arc tangent. The top is the magnitude of the vertical component, and the bottom is the magnitude of the horizontal component, and equals arc tangent 11.87 over 19.15, and this equals 31.79 degree. So the total force, or it's also called net force, equals magnitude 22.53 Newton, and its direction is just 31.79 degree above the ground, above the horizontal. Now question B, we use force 1 to represent the force that one child exerts on the sled. So force 1 is 15 Newton, and direction is north and 35 degree toward east. And we use F2 to represent the force that the second child exerts on the slide. So F2 is 25 Newton. Direction is north and 54 degree toward west. Then I draw the FBD. So this direction is north, also positive y direction, and this direction is east, also positive x direction. And this dot represents the slide. And this is force 1. This is force 1, just the force that the first child pulls the slide. And this angle is 35 degree. And this is force 2. The second child pulls the slide with this force, and this angle is 54. It's north, then turn 54 degree to west. So this is just the FBD of this question. Analyze force 1 first. So this vector represents force 1. And this vector is just the force 1x. It's a horizontal component. And this vector is just force 1y, the vertical component of force 1. And this angle is a right angle. And this angle is just 35 degrees. And from this graph, we can know that force 1x just equals force 1 multiplied sine 35 degrees and equals 15 multiplied sine 35 degrees and equals 8.6 Newton. And force 1y, its vertical component equals force 1 multiplied cosine 35 degrees equals 15 multiplied cosine 35 degrees equals 12.29 Newton. Now I analyze force 2. So this vector is force 2. This is force 2. And this vector is just its horizontal component f2x. And this vector is force 2's vertical component f2y. And this angle is 54 degrees. This is a right angle. And from this graph, we can know that f2x, its horizontal component, equals negative f2 multiplied sine 54 degrees. It's negative because its direction is the negative direction. Its direction is to the west. It's the negative direction. So this equals negative 25 multiplied sine 54 degrees equals negative 20.23 Newton. And its vertical component f2y equals f2 multiplied cosine 54 degrees and equals 25 multiplied cosine 54 degrees and equals 14.69 Newton. Now we can get the x component of the net force equals the x component of force 1 plus the x component of force 2, and this equals 8.6 plus negative 20.23 equals negative 11.63 Newton. And the vertical component of the net force Fy, sigma Fy equals the vertical component of F1 plus the vertical component of force 2, F2y, and equals 12.29 plus 14.69 and equals 26.98 Newton. Now I draw the graph of the net force. This vector is its horizontal component, sigma fx, and this vector is its vertical component, sigma fy. And this vector is just the net force, sigma. And this angle is theta. This angle is a right angle. Now we know the magnitude of sigma f equals square root its horizontal component square plus its vertical component square and equals square root 11.63 square plus 26.98 square and equals 29.3 38 Newton. Then the angle theta equals arc tangent. The top is the magnitude of its vertical component. The bottom is the magnitude of its horizontal component, and equals arc tangent 26.98 over 11.63 and equals 66.68 degree. So the net force sigma F equals its magnitude 29.38 Newton, and its direction is first west, then turn 66.68 degree toward north. Question C. There are three forces. So the force of gravity, this force is 440 Newton, and the direction is down. Then tension force 1, this force is 430 Newton, and the direction is up and 35 degree left. The tension force 2, this force is 280 Newton, and the direction is up. Then I draw the graph. So this direction is up and also positive y direction. And this direction is right, also positive x direction. And this dot represents the performer. And this is the force of gravity. Force of gravity. Now this is force 1. And this angle is 35 degree. And this is force 2. The direction of force 2 is up. Then I just analyze force 1. So this is force 1. This is just the force 1's horizontal component, F1x, and this is force 1's vertical component, F1y, and this angle is 35 degree, and this angle is a right angle. So from the graph, we can know that force 1's horizontal component, F1x, equals negative force 1 multiplied sine 35 degree. It's negative because its direction is the negative direction. It's to the left. It's opposite to the right, the positive x direction. This equals negative 430 multiplied sine 35 degree. And this equals negative 246.64 Newton. Then force 1's vertical component F1y equals force 1 multiplied cosine 35 degree. And this equals 430 multiplied cosine 35 degree and equals 352.24 Newton. Then we can get the x component of the net force sigma Fx just equals F1x, because in the horizontal direction there is only one force, it's F1x, and this equals negative 246.64 Newton. Then the vertical component of the net force sigma Fy just equals F1 y, force 1's vertical component, plus F2, because F2's direction is just the positive y direction, it's up. Then minus Fg. It's minus because Fg's direction is the negative y direction. Its direction is negative, so then this equals 352.24 plus 280 minus 440 and equals 192.24 Newton. Now I draw the graph. This vector is sigma Fx, the net force horizontal component. And this vector is the net force vertical component, sigma Fy. Now this vector is the net force, sigma F. This is a right angle, and this angle is theta. From the graph, we can know that the magnitude of the net force, sigma F, equals square root its x component square plus its y component square, and equals square root 246.64 square plus 192.24 square, and equals 312.71 Newton. Now the angle theta equals arc tan theta. Then the top is the magnitude of its vertical component. Bottom is the magnitude of its horizontal component, and equals arc tan theta. Top is 192.24. Bottom is 246.64 and equals 37.93 degrees. So the net force, sigma F, is magnitude 312.71 Newton. And the direction is first left, and from left, turn 37.93 degrees toward up. Because this direction is left and this direction is up.